It's important to properly dispose of unwanted medication or sharps. MedProject offers free and convenient disposal options near you. To learn more, call 844-MED-PROJECT or visit medproject.org.
Celebrate Thanksgiving with Safeway. This week at Safeway, get whole Signature Farms frozen turkey, 10 to 15.5 pounds for $8 each, or 16.1 to 22 pounds for $10 each. Member price with a minimum $50 purchase, limit one per household. Plus, packs of Coca-Cola, Pepsi, 7-Up, Dr. Pepper, or AHA Sparkling Water are buy two, get three free. Limit 3 free items. Also this week, get 5-pound bags of Signature Farms russet potatoes for 97 cents each with digital coupon. Limit 1. Visit Safeway.com or head in store for more details.
This is SpaceTime, Series 24, Episode 97, for broadcast on the 30th of August 2021. Coming up on SpaceTime, new observations suggest the planet Saturn has a fuzzy core. Extraterrestrial radioactive isotopes discovered on Earth. And it's official, NASA's mission to put people back on the Moon delayed by at least a year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has concluded that Saturn's core is a fuzzy diffuse soup of ice, rock, and metallic fluids rather than a solid terrestrial sphere. The findings, reported in the journal Nature Astronomy, are based on an evaluation of observations of ripples in Saturn's majestic ring system. In the same way that quakes on terrestrial worlds can provide insights into their internal structures, oscillations in Saturn's interior cause the gas giant to jiggle, which in turn causes ripples in its rings. The findings, based on 13 years' worth of observations by NASA's Cassini spacecraft, also suggest that Saturn's core is huge, extending across 60% of the planet's entire diameter, making it substantially larger than previously estimated. The data also shows that Saturn's core is some 55 times more massive than the entire Earth, with 17 Earth masses of that being ice and rock, and the rest a fluid of metallic hydrogen and helium. The study's lead author, NASA's Christopher Mankiewicz, says the findings offer the best evidence yet for Saturn's fuzzy core, and are also in line with recent evidence from NASA's Juno mission, which suggests that Jupiter may also have a similar diluted core. He says these fuzzy cores are a lot like a sludge of hydrogen and helium gas, which gradually mix with greater and greater amounts of ice and rock the deeper one moves towards the planet's center. Mankiewicz says Saturn is always quaking, but it's subtle, with the planet's surface only moving at about a meter every 1 or 2 hours, like a very slowly rippling lake. And that's a rather appropriate analogy, because Saturn's overall density is incredibly light. In fact, it's less than water, which theoretically at least means if you could put Saturn on a lake, it would float. Like a seismograph, Saturn's rings pick up these gravitational fluctuations, and the ring particles then start to wiggle around in response. The gravitational ripples also show that while sloshing around as a whole, Saturn's interior is composed of stable layers that formed as heavier and heavier metals sank towards the middle of the planet and stopped mixing with the lighter materials above them. Classic differentiation. And that's only possible if the fraction of ice and rock gradually increases with depth. Of course, there's a big problem with all this. The findings challenge current models for gas giant planetary formation. Those models have always held that the rocky cores formed first, and then they attracted large gaseous envelopes. But if the cores of the gas giants are indeed fuzzy, and the data on Saturn and Jupiter tend to suggest that's the case, then planets might instead incorporate gas a lot earlier in the process. And that'll give astronomers a lot to think about. This is SpaceTime. Still to come, extraterrestrial radioactive isotopes discovered on Earth, and NASA's long-awaited mission to send people back to the Moon delayed by at least a year. All that and more still to come on SpaceTime.
Celebrate Thanksgiving with Safeway. This week at Safeway, get whole Signature Farms frozen turkey 10 to 15.5 pounds for $8 each, or 16.1 to 22 pounds for $10 each. Member price with a minimum $50 purchase. Limit one per household. Plus, packs of Coca-Cola, Pepsi, 7-Up, Dr. Pepper, or AHA sparkling water are buy two, get three free. Limit 3 free items. Also this week, get 5-pound bags of Signature Farms russet potatoes for 97 cents each with digital coupon. Limit 1. Visit Safeway.com or head in store for more details.
Scientists are needing to rethink the possible origins of some of the heaviest elements on the periodic table, following the discovery of plutonium-244 alongside radioactive iron-60 in Earth's oceanic crust. The findings, reported in the journal Science, suggest the two isotopes are evidence of violent cosmic events in the vicinity of Earth millions rather than billions of years ago. Light elements like hydrogen and helium, together with tiny amounts of lithium and beryllium, were formed during the creation of the universe in the so-called Big Bang 13.8 billion years ago. Elements heavier than hydrogen, going right up to iron, can be fused in the cores of stars through a process called nucleosynthesis. But some even heavier elements, like say gallium and bromine, need something more, such as the explosive death of a star in an event called a supernova. And still even heavier elements such as gold, uranium and plutonium, which are the most neutron-rich, require a process called rapid neutron capture, in which the atomic nucleus is bombarded with neutrons so fast it doesn't have time to split apart. These types of events were always thought to be caused by far more violent events than supernovae, such as the merging of two neutron stars, the superdense stellar cores of stars far more massive than the Sun that have already gone supernova. The problem is the discovery of plutonium-244 in the Earth's ocean crust, dare I say, muddies the water, forcing scientists to rethink the origins of these elements. The study's lead author, Professor Anton Wollner from the Australian National University, says the discovery suggests a complex picture. You see, any plutonium-244 or iron-60 that existed when the Earth formed from interstellar gas and dust some 4.6 billion years ago would have long since decayed. So, the current traces which have been detected on the ocean crust must have originated far more recently, from some fairly recent cosmic event in space. Wollner says the discovery suggests that the plutonium may have formed in a supernova, or it's left over from something even more spectacular, such as a neutron star detonation. Wollner and colleagues used the Vega accelerator at ANSTO, the Australian Nuclear Science and Technology Organisation in Sydney, to identify the tiny traces of plutonium-244. Wollner says the dating of the sample confirms 2 or more supernova explosions must have occurred near Earth. He says this data could be the first evidence that supernovae do indeed produce plutonium-244. Or it could be that it was already in the interstellar medium before the supernova went off, and it was simply pushed across the cosmos to rain down on Earth together with a supernova ejector.
We were searching for 2 radionuclides. One is a form of iron, this is iron-60, and the other one is a very heavy one, this is plutonium-244. These are very neutron-rich nuclides, and they do not naturally exist on Earth. They would have existed on Earth while the solar system has formed, but they have decayed away since then. So the idea was if we find some radionuclides like iron-60 or plutonium-244, it's very likely that they have been produced in space. There is a bit of anthropogenic production. This means man-made production of iron and plutonium, but this is very much related only to the last 70 years or so since nuclear activities have started.
These particular elements were found at the bottom of the ocean, in ocean sediments.
Yes. So we were looking for pretty remote areas, and in the deep ocean there are sediments and crusts which grow very slowly over time, and they incorporate particles and atoms which are in the ocean. And this is happening over millions of years. So we had samples that cover the time period from present up to about 10 million years into the past. And we had a time profile. So we could different layers. The different layers correspond to different times in the past. And we could identify then different concentrations of the very rare atoms.
And by doing this, what was the picture you were able to build up?
What we found is, first of all, we found an enhanced concentration of this iron-60. Iron-60, we know, is largely produced in supernova explosions. And supernova explosions happen in our galaxy maybe about 2 times per 100 years, this we know. And now it can happen that such a supernova explosion can take place close to the solar system. And the ejected material from the supernova can penetrate deep into the solar system and may eventually find its way into this deep sea crust or deep sea sediments. And there it was where we found these atoms. And actually we found 2 signals. One, enhanced influx of this very special supernova indicator. This was between 1 and about 3 to 4 million years before present. But there was also a second influx at around 6.5 to 7 million years ago. So this iron-60 presence tells us that in the last about 10 million years, there were 2 events of supernova explosions close by to the solar system.
Are these likely to be the progenitors to the local bubble that we're going through now?
Exactly. We don't know exactly the history of the local bubble, but there are models which actually simulate the conditions, and they predict or suggest that about maybe 10 to 15 supernova explosions might have happened in the last 10 to 15 million years and are responsible for this structure in the interstellar medium. Because the solar system itself is now traveling through a void or a volume which is pretty much low in density of interstellar particles. And the idea is that the supernova explosions basically emptied this volume in the last few million years. And so it's pretty likely that one of these supernova also had been close by to the solar system at some stage, so that it could eventually deposit some of its material directly into the terrestrial archive.
And what makes that even more interesting is that we think we can see the remnants of all that in the Pleiades open star cluster.
There are some
That's one
models
theory
which
anyway,
try to, exactly. So they try to reconstruct the trajectories.
Yeah.
So if we know that the supernova explosions happened maybe 2.7 million years ago, it's not clear because the influx is pretty broad and we don't know, or even we do not understand yet why this influx, at least the younger one, is so broad. Maybe it's not 1, but it's 2 or even 3 supernova explosions which have caused this rather long-term influx. So people try to
draw a
model
long bow sometimes.
People try to model the trajectories of these progenitor stars, and one could be what you mentioned, but there are other candidates as well. Important is that at the time, about 2 to 3 million years ago, these progenitors must have been within a distance of, let's say, between 50 to 100, 120 parsecs or so. And people are trying to get more information now also from observations to see if they can get better data in order to have a more precise trajectory developed back into the past.
What about the plutonium-244?
The plutonium-244 is a bit different because in contrast to iron-60, we do not know where it is produced. And this is one of the candidates for the so-called R process. And R process is a process which we know exists in nature, and it is responsible for the production of about half of the heavier elements. Of the heavier elements means above iron and heavier. We know that there's still a burning phases, but the second half of this process is still a mystery. And in particular, plutonium-244, because it's a very heavy nuclide, is produced in this process. And there are 2 candidates which were believed in the past could synthesize these elements. And one is, again, supernova explosions, like iron-60, and the other one would be neutron star mergers, for example. Difference between these 2 is that neutron star mergers are very rare events, about a factor of 1,000 or so rarer than supernova explosions in our galaxy. And our idea was then to see, can we find plutonium-244 together with iron-60? Because then it would be an indication that at least plutonium-244 somehow must be correlated to the iron-60 influx. And maybe even we could link it to supernova production of this isotope. And indeed, we did see see some of plutonium-244 in our samples correlated with the iron-60. Interestingly, however, is that the concentration of plutonium-244 seems to be too low in order to explain that supernova make all the R-process elements. So we see some of the plutonium, but maybe not enough. It's not sufficient that supernova can explain all the abundance of the heavy elements which are produced in this R process. Plutonium-244 has a half-life of 80 million years. This is short compared to the typical times it is required to generate the next generation of stars. But what is discussed and which would be possible, at least from our data, is that the neutron star merger produced the plutonium-244, and then it was ejected into the interstellar medium. And when at a later time, then supernova went off independently, It pushed away also the material from the interstellar medium that contains the plutonium-244. So the freshly produced iron-60 and the older plutonium-244 may have been pushed against the solar system together. The plutonium-244 being produced much longer time ago, and the freshly produced iron-60 end up at the same time in this crust material, so in the deep sea sediment.
Do we find the plutonium-244 in both iron peaks?
Yes, we find it in both iron peaks. One thing still is that for iron, we have a much higher concentration. It's about 4 orders of magnitude more iron-60 in this crust than plutonium-244. So the detection of plutonium is even more difficult. And for this, we had very broad layers, which means we only had 3 independent layers for this crust material covering these 10 million years. So we have no good time resolution in here. The next step would be, this is now in progress, we have a much larger sample which allows us to get a better time resolution of this influx, maybe to have a better idea if the plutonium really follows the time profile of the iron-60. At this stage, we just see that during these 2 peaks, the concentration of plutonium and iron the ratio seems to be similar. The concentration itself is lower for the older one, but this is correlated. So iron is lower and also plutonium-244 is lower. This gives us some hints that this is a correlation between these two. But whether the origin, the production is the same, is supernova or not, is difficult to judge at this time. What we know, of course, is that the concentration of plutonium-244 seems to be lower, as mentioned before, in order to explain that supernova can produce all the R-process elements. This is the other finding.
It makes it sound like we're in a pretty busy part of the galaxy.
If you look and do the math, then you see 2 supernova explosions per 100 years, means roughly that you would expect every 3 million years or so, on average, a supernova explosion that happens close by, so that you might find traces of it in some terrestrial deposits. So it's not unlikely that this happens. It's rather unlikely if it becomes so close that you would expect a direct impact, let's say mass extinctions or maybe a climate response, things like this. This is another story.
That's Professor Anton Wollner from the Australian National University. And this is SpaceTime. Still to come, NASA's mission to return people to the moon delayed by at least a year, and in case you missed it, we just had a blue moon. Or did we? All that and more still to come on SpaceTime. NASA's hopes of sending people back to the lunar surface in 2024 have just been dashed because of delays in the new spacesuits being developed for the mission. A new report from NASA's Office of the Inspector General has confirmed that the new Exploration Extravehicular Mobility Units, or XEMUs as the spacesuits are called in NASA speak, won't be ready until at least April 2025 at the earliest. And that's well after the planned November 2024 launch date for the Artemis 3 mission, which is meant to put people back on the lunar surface. NASA needs to have 2 flight-ready XEMUs available for the mission. Using the original Apollo-era spacesuits, which formed the basis of those used for spacewalks during the Space Shuttle era and are still used today aboard the International Space Station, would simply never work. That's because the Apollo crews not only found them difficult to walk around and bend over in, But they found the razor-sharp glass-like lunar dust was literally cutting into the suit fabric after just a few hours, making them potentially deadly. The new spacesuits are designed to overcome these issues, providing greater protection, improved mobility and flexibility, and also better communications. No more of those Snoopy caps. But instead of NASA using a single manufacturer, their new spacesuits' 92 primary components are being supplied by 27 different companies. Add to that continuous changes in their specifications, such as cutting the mass of each spacesuit from 186.6 to 177.1 kilograms, and not only is the development schedule blown out by some 20 months, but so too is the budget, to well over $1 billion. The Artemis program is complicated. It involves NASA's new Boeing-managed SLS Super Heavy Lift rocket launching a new Lockheed Martin-built spacecraft called Orion, carrying a crew of 4 to the Moon, where they'll rendezvous with a new yet-to-be-built lunar space station called Gateway. Docked to Gateway will be the SpaceX-developed spaceship HLS, or Human Landing System. It's based on the reusable Starship launch system now being developed in Texas. But because it'll only be used around the Moon, it won't need the atmospheric heat shields or air brakes, and instead will feature mid-body landing thrusters to avoid lunar regolith dust plumes. Of course, the Gateway space station may not be ready in time, in which case the Orion capsule will dock directly with the Starship HLS. The first SLS is now being assembled or stacked at the Kennedy Space Center's Vehicle Assembly Building. It'll be used for the Artemis 1 test flight mission, which will carry an unmanned Orion capsule to the Moon and back in November. Now, if all goes well, Artemis 1 will be followed by an Artemis 2 mission, and that will take a crew of 4 astronauts around the Moon and back, probably sometime around 2023. And then comes the historic Artemis 3 flight to the lunar surface, now scheduled for some time in the middle of 2025. We'll keep you informed. This is SpaceTime. Still to come, we've just had a blue moon. Or did we? We'll explain all that in a minute. And then later in the science report, July has gone down in history as the hottest month ever recorded on planet Earth. All that and more still to come on SpaceTime. Well, in case you missed it, the full moon on Sunday, August the 22nd, was a blue moon, according to the original but not the most popular definition of the term. In modern usage, the term blue moon has come to refer to the second full moon in a month. The last time that occurred was back on October the 31st, 2020. But that hasn't always been the case. See, this popular definition was actually a journalistic and editorial goof-up in the pages of Sky and Telescope magazine back in March 1946, and then spread around the world from there. The traditional astronomical definition of a blue moon actually goes back to the Maine Farmer's Almanac in the late 1930s. The almanac consistently used the term to refer to the third full moon in a season containing 4 rather than the usual 3 full moons. Sky and Telescope's observing editor, Diana Honey-Kanan, says introducing the term blue moon meant that the traditional full moon names, such as wolf moon and harvest moon, stayed in sync with their seasons. But in 1946, amateur astronomer and frequent contributor to Sky and Telescope magazine, James Hugh Pruitt, incorrectly interpreted the almanac's description, and the idea of the blue moon being the second full moon in one calendar month was born. By either definition, blue moons are relatively rare. On average, they happen about once every 2.7 years. We get a true blue moon, that is the third full moon in a cycle of 4 in a season, when the cycle of lunar phases causes a full moon to occur within a few days of either an equinox or a solstice. The last such occurrence was in February 2019, and the next will be in August 2024. On the other hand, we get the Sky and Telescope blue moon after a full moon occurs on the first or second night of a month having 30 or 31 days, respectively. Because of this, there can never be this type of blue moon in February because full moons occur every 29.5 days. And in case you're interested, the next second full moon in a month blue moon comes in August 2023. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. July has gone down in history as the hottest month ever recorded on Earth. July's average temperature worldwide was 16.73 degrees Celsius, or if you prefer the old scale, 62.08 degrees Fahrenheit. That's 0.93 degrees Celsius or 1.68 degrees Fahrenheit above the 20th century average of 15.8 degrees Celsius or 60.4 degrees Fahrenheit. It's the highest average monthly temperature since official record-keeping first began 142 years ago. The findings by the United States National Oceanic and Atmospheric Administration NOAA are based on combined global land and ocean surface temperatures. As well as setting a new global record, it was also the 4th warmest July in Australia and the 6th warmest in New Zealand. A new study warns that vaping impacts your body from the very first drag. Previous research has already shown that both tobacco and e-cigarettes increase your levels of cellular oxidative stress, which assists in the development of many diseases. For the new research, scientists tested the level of cellular oxidative stress in a group of 32 people, both before and after either vaping or sham vaping, puffing on a straw without nicotine. The findings, reported in the Journal of the American Medical Association, show that of the 11 participants who had not previously smoked or vaped, researchers recorded an increase in cellular oxidative stress in those who vaped, but not those who sham vaped. On the other hand, those participants who were already regular tobacco smokers or e-cigarette users, researchers didn't record any increase in cellular oxidative stress after one vaping session. However, their baseline cellular oxidative stress levels were already found to be far higher than for non-smokers. Swiss researchers have set a new record for the famous mathematical constant pi. They've now calculated it to 62.8 trillion places using a supercomputer at the Graubünden University. The calculation took 108 days and 9 hours. Pi, usually simply represented as 3.14159, is defined in Euclidean geometry as the ratio of a circle's circumference to its diameter, and it appears in many formulas in all areas of mathematics and physics. By the way, the world record for memorizing pi stands at over 70,000 digits. Imagine sitting next to that guy at a dinner party. Phrenology is the discredited study of the relationship between cranial sizes and shapes as a proxy for brain size and shape. Practitioners of this pseudoscience believe themselves to be able to use this information as an indicator of both the character and mental abilities of the person whose brain is being investigated. Now, it might all be woo, but the vestiges of phrenology do remain, and they're still being used to justify some common beliefs and inferences. Now, a bunch of Frankenstein-type scientists have used human genes to try and make monkeys' brains bigger. Clearly a step towards some kind of Planet of the Apes movie scenario where monkeys develop human intellect and take over the planet. Of course, that could only work if phrenology was real. But because just as a human with a smaller than normal brain doesn't result in a loss of human intellect, a monkey with a larger than normal brain didn't make it any smarter, just very sick and in a lot of pain. Tim Mendham from Australian Skeptics says, it's strange that beliefs such as phrenology can stick around and flourish even among so-called educated people. He says it shows how easily groupthink happens, even in science.
Let's go to the bumps on the head first. That's phrenology, where you can sort of shave someone's hair off, move your hands across someone's skull, almost like you're reading a crystal ball, sense where the bumps are.
Isn't this what the Third Reich were into?
Yeah, the Third Reich was into a lot of stuff, including flying saucers and astrology and Nostradamus. You name it, they were into it. But phrenology was sort of made up 150 years ago or so, very much a Victorian-era science by which they reckon they could read the character of people by the bumps in the head. And you get those famous, quite attractive-looking little statuesque busts of heads with all the top of the head divided up into little bits and pieces. That's not necessarily about which part of the brain they're looking at, it's actually which part of the skull. And so the bumps on the head. There's suggestions later on that does the brain affect the exterior of the skull? No, not necessarily. You might have had a bump at some stage which has done something to your skull. But what they're suggesting is that you don't need all of your brain, that some people following accidents, etc., only have a partial brain, that some animal experimentation, they can remove part of the brain, and that...
Well, wasn't there that dude who was born with literally just a very thin coating of grey matter
on the underside of the skull, on the inside of the skull, and virtually the rest was empty, just fluid.
And he operated fine?
He worked fine, yeah. He wasn't Einstein, but he lived a normal life.
He was still doing podcasts?
Still is. Love it. No, there was this guy who... Very seriously, there was this guy who, when they did an X-ray on him, he did have a lower IQ, but nothing that would hint at what was actually going on inside. And he had just a few millimeters of grey matter coating the inside of the skull, or whatever the tissue is that sits on the inside of the skull that protects the brain. Just had a little bit of that, and the rest was all spinal fluid. You would never have known there was nothing there.
He was operational. He could actually, yeah.
He was quite functional, yeah.
Yeah, and you get the variation depending on how much your brain... Now forget the idea that you only use 10% of your brain anyway.
That's a lie.
No, that's crap, yes. But I mean, yes, you don't need all of the brain to actually be functional. You might not be as functional in every area as you would like to be. The trouble is that has nothing to do with phrenology, of course, because you assume the people who have been phrenologized who have their quota of brain. But I mean, it's an article that's suggesting that it moves from phrenology to brain size and how much brain, and they're suggesting that you could take some human brain and put it in monkey brain and mix it up together with a mix it up together, but anyway, and that would increase the intelligence of monkeys and apes, and therefore you end up with Planet of the Apes, basically. The apes take over and leave the rest of us behind. It's a long bow to draw, whatever the expression is, in some of this stuff, which you sort of say, yeah, well, sort of. But to go from phrenology to indicate how much brain power you have to how your brain can be used, it's an interesting journey for some people to take as a thought experiment almost. But the link between skull shape and brain activity is... well, there's no link.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.